Hi everyone. We're about to start our unit on force and motion, and I thought it would be a good idea to just spend a little bit of time talking about what motion is. I thought this would be pretty easy, fairly straightforward, and a nice place to start. But I soon found that it was a little bit more complicated than you would really think. What is motion anyway? Well, if we were to consider me sitting in a chair as I am right now, making this podcast, I'm not really moving. My chair is staying in one place and I'm sitting in it. However, the simple fact of the matter is, once I started thinking a little bit, I realized I am in fact moving. I'm moving really pretty fast. I mean, if I were to take my little chair and I were to show me here on planet Earth, you'll notice that I'm up in North America, right in Connecticut, I'm in fact moving very, very fast. Think about it. We all know that our Earth has a north and a south pole, and we know that the Earth rotates around its axis. It rotates all the way around once every 24 hours. That's how we get our day and night. So in fact, even though I'm sitting here in my chair and I'm not moving in my chair is zipping along through space at a pretty quick clip. Now I was thinking, how can I demonstrate if I'm sitting in this chair that I'm really not moving at all? So what if I were to take this chair and I were to stick it right here on top of the North Pole? Well, I'm sitting in the North Pole, I'll get a nice view, but I'm not going to be changing my position at all relative to the Earth's axis. So there you have it. I'm sitting still, right? No, not really. Because if you recall, our Earth is going around our sun. We revolve around our sun at a pretty quick pace. We can go all the way around the sun once every 365 days. So if you think about it, I'm actually traveling at the incredible speed of 16 miles per second. Not 16 miles per hour. That's what you might be driving down your road in your neighborhood, but 16 miles per second. Hurtling through space, me sitting here on my chair. So, in fact, you might start to realize that this whole motion thing is a little bit more complicated than I had originally thought that it might be. So, if I'm sitting in my chair here in Connecticut, I'm not moving. Or am I? I am, in fact, moving relative to the axis and relative to the sun. So, here's a first crack at a definition of motion. An object is in motion if its position changes relative to another object. So here we have me relative to the chair. I'm not moving, but when you consider it in relation to the axis of the Earth, I'm moving pretty quickly. And then when you consider it in relation to my position to the sun, I'm moving really pretty fast. We call these objects reference points. A reference point is just an object used for comparison to determine if something is moving. And it doesn't need to be anything as grand as the sun or the Earth's axis. You can look at it in relation to other things. I know that it's happened to me when I'm sitting on the bus or sitting on a train, and even though my train's not moving, the train or the bus next to me starts to move, and my heart stops like, oh wow, I'm moving. When in fact I'm not. It's just my frame of reference got a little bit messed up. What we can do now is define motion with the following definition. An object is in motion if it changes position relative to a reference point. I have a nifty little example here that I'd like to show you about relative motion. Here we have a scenario. This little applet was written such that the blue here indicates a stream. And you'll be able to monitor the motion of the stream by looking at these yellow dots right here. You have two boats that are on the river or the stream, and then you also have this little person indicated in blue, and then finally you have the ground, which is shown by these black dots right here. So what I'd like to do is show you how your reference frame or your frame of reference can change how things appear to be moving. For example, if I were to start with my reference point being the ground is not moving at all. However, I can see the little blue person is moving away from me. The water, indicated by the yellow dots, is moving down the river, and the boats are moving at a pretty good clip down the river away from me. Now let's change our frame of reference to the man. Now it looks as though the land or the ground is moving away from me backwards. The river is still moving forwards, but not quite so fast, and the same thing with the boats. If I were to change my frame of reference to the river itself, you'll notice that the frame of reference, the river, is no longer moving, but it seems as though the ground and the man are moving backwards. Finally, I'm going to move my frame of reference to the boats. As you can see, when you're on the boat is no longer moving, but the ground and the man and the river are all moving behind you at a really rapid pace. So it just goes to show you that frame of reference has a lot to do when we're considering motion. What I'd like to finish up by doing is share with you a couple of really great videos that I found on YouTube. Now, all I did was when I went to YouTube, I typed in frames of reference 1960. And the reason why I did that is because the National Science Foundation and the Ford Foundation and the Alfred P. Sloan Foundation put together a whole presentation about frames of references. It's divided up into 3 approximately 10-minute sections. If nothing else, I encourage you to spend 10 minutes and watch the film. You'll enjoy seeing these physicists at work and some really great technology from the 1960s. But at the end of the day, I think it is one of the best examples that I could find showing how frames of references can really affect your perspective. At this point in time, what I'd like you to do is look at your notebook, figure out what questions you need to answer. If you can't answer any of them completely, go ahead, rewind this video, see where the information is, and then you can copy it down in your notebook. Look forward to discussing this with you in class tomorrow.